2, Unit 6, Lesson 2b, on factoring the sum and difference of cubes. As with factoring the difference of squares, we know that a squared minus b squared actually factors in the formula a plus b, a minus b. There is a pattern for factoring the sum and difference of cube. So, in order to do the sum and difference of cubes, it helps if we know what some of the perfect cubes are. We know for perfect squares, for example, 9 is a perfect square because 3 squared is 9. So let's go through the list of the first 10 perfect cubes. Most of the time, probably 1 through 5, if you know enough of those, that should be enough, but you do run into some other ones, so let's do those. Alright, 1 cubed we know is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3 is 27. 4 cubed is 4 times 4 times 4 is 64. 5 cubed is 5 times 5 times 5, which is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1,000. So these are the most commonly used ones. Probably if you know 1 through 5, you can probably recognize those most often, but you do run into 6 and above occasionally. If you're not sure, you can always take the cube root of something to see if it's a perfect cube. Now, variables are also perfect cubes if their exponents are divisible by 3. So remember that, for example, x to the 4th is a perfect square because x squared times x squared is x to the 4th. Now remember, a perfect cube is something that can be multiplied 3 times to get itself. So if we have x to the 6, what cube to give you x to the 6? Well, it would be x squared, because x squared times x squared times x squared 3 times is x to the 6th. So x to the 15th is actually a perfect cube also because x to the 5th cubed is x to the 15th. Now that we know what the perfect cubes are, let's take a look at actually factoring them. There is a formula for factoring perfect cubes. They are factored as into the product of a binomial and a trinomial. So you'll have a 2-term polynomial and a 3-term polynomial of the factors. And a good way to remember the signs for the factors, no, there's one sign here and there's 2 signs here in the trinomial. You can use the acronym SOAP. It stands for same, opposite, always positive. So I'll look at that in just a second. Alright, so let's look at the sum of cubes and the difference of cubes. The sum of cubes means the first term and the last term are perfect cubes. The first term and the last term are perfect cubes, and there is a plus in the middle. That would be the sum of cubes. For the difference of cubes, it's a cubed minus b cubed perfect cubes with a minus in the middle. Alright, now remember I said that to do the pattern, it's going to be a binomial and a trinomial. So the first thing that we need to do is figure out our signs. The signs, remember, is SOAP. So, for the binomial, there is one sign here. In the binomial part, that's the same. So if this is plus, this is going to be plus. If this one is minus, this one's going to be minus. Okay? Now, in a trinomial, there are 2 signs, one here and one here. So, the next sign is the opposite sign of whatever this one is. So, if this one is plus, this sign is going to be minus. And since this one is minus, this is going to be plus. Same, opposite. Same, opposite. And then, the last sign is always positive. AP is your SOAP. Same, opposite, always positive. Same, opposite, always positive. So all we have to do is plug in what goes in each of the places and we know what to do. Alright, now your pattern for your sum and difference of cubes is always going to be A, B, A, B. And then A squared, AB, B squared. A squared, AB, B squared. So that is the pattern. So what you need to know is what A is for each one of these. Now remember, these are cubes. So you want to know what the cube root is for each one of these terms. And then you just take each term and square it, multiply a and b together, and then square b squared. So let's try this out. X cubed plus 8. X cubed is a perfect cube. 8 is a perfect cube. It's got a plus in the middle, so we want to use this pattern. So we have to know what a and b are. So if we have this as x cubed plus something cubed to give you 8, what cubed gives you 8? Well, that would be 2 cubed. So that means that a is x, and the b value is actually going to be 2. X cubed plus 2 cubed, because that gives you 8. So just follow your pattern. Make your bubbles, little bubble, big bubble, same sign, opposite sign, always positive. And plug in your values. A plus b would be x plus 2. And then square the a. This is going to be x squared. And then it's going to be x times 2, because it's a times b. And then b squared is going to be 2 squared. All right, now simplifying. I wrote this out. I know you can probably do this in your head, but you can see where the values are coming from. Is x squared minus 2x, and then 2 squared is 4. And that's your pattern. Now, if you want to remultiply to make sure this works, just use a double distributive. You want to do x times x squared is x cubed. X times negative 2x is negative 2x squared. X times 4 is 4x. And then multiply 2 times x squared is 2x squared. 2 times negative 2x is negative 4x. And 2 times 4 is 8. And combine your terms, you end up with x cubed. These cancel, plus 8. And there's your factors. So what you have to be able to do is figure out what the cube root of each one is, figure out what your a and b value is, and just follow the pattern. All right, let's look at x cubed minus 1. X cubed is a perfect cube, 1 is a perfect cube, and it is a difference of cubes, so we want to follow this pattern. Now remember, let's write these as cubes. We know x cubed is a perfect cube, so this is x cubed. And then 1 is also a perfect cube because 1 cubed is 1. So that means that a is x and b is going to be 1. So follow your pattern. All right, so we have a is x minus b, which is 1. A squared, you can do this in your head, is x squared, plus a times b would be 1 times x, which would be x, and then b squared is 1 squared, which is 1. And there we go. And you can, if you want to remultiply this to check, x times x squared is x cubed, x times x is x squared, x times 1 is x, then multiply by negative 1. Negative 1 times x squared is negative x squared, negative 1 times x is negative x, negative 1 times 1 is negative 1. Combine your terms, these cancel, x cubed minus 1. It works. So that's your pattern. The tricky part of it is making sure you know what the cube roots are so that you can do this. All right, so just follow the pattern. 27x cubed minus 8. Well, 27 is a perfect cube, x cubed is a perfect cube, so that makes it a whole thing a perfect cube. And then 8 is a perfect cube. Now, let's write these as cubes. So 27x cubed is actually 3 cubed x cubed. So this is 3x quantity cubed. 3 cubed, x cubed. There's 3x quantity cubed. So you take 3x times 3x times 3x, it's 27x cubed. And 8 we did back here, we know is 2 cubed. So that means that a is actually going to be 3x, and b is going to be 2. So let's follow the pattern. Here's your pattern. A minus b. 3x minus 2. Now, here's where it's a little tricky. You have to square the entire 3x. And then plus 3x times 2, and then plus 2 squared. All right, now the tricky part is this one. When you square 3x squared, remember it's actually 3x times 3x. So this is going to be 3x minus 2. 3x quantity squared is 3x times 3x, which is actually 9x squared. Make sure you square the entire thing. 3x times 2 is 6x, and then 2 squared is 4. And there you go. So we have 27x cubed minus 8. If you remultiply this, 3x minus 2, 9x squared plus 6x plus 4, you will get 27x cubed minus 8. All right, let's try this one. X to the 9th plus 64y to the cubed. We know x to the 9th, written as a perfect cube, is x cubed cubed. And then 64y cubed would be, well, cube root of 64 is 4y quantity cubed. So that means that A is going to be x cubed and B is going to be 4y. All right, so let's do our pattern here. This is the sum of cubes. So it's going to be same, opposite, always positive. All right, square the first one. X cubed plus 4y, it's the same one. A plus B. Now the first term is going to be squared. What is x cubed squared? Is actually going to be x cubed times x cubed, which is x to the 6th. Multiply these together. 4y times x cubed is minus 4x cubed y. And then square the b. Remember, this is 4y times 4y, which would be 16y squared. So x cubed plus 4y, x to the 6 minus 4x cubed y plus 16y squared. 125 minus x to the 15th. What are they as perfect cubes? Well, 125 is 5 cubed. And then x to the 15th is actually x to the 5th times x to the 5th times x to the 5th. So it's x to the 5th cubed. So A is 5 and B is x to the 5th. All right, now this is a difference of cubes. Here's your bubbles. Big bubble, small bubble, big bubble. All right, and it's going to be same sign, opposite sign, always positive. Fill in your values. A minus B would be 5 minus x to the 5th, and yes, it has to be in that order because that's the way it's set up here. All right, and then A squared would be 25. AB is 5 times x to the 5th. And then B squared is x to the 5th squared, which is x to the 5th times x to the 5th, which would be x to the 10th. And there we go. So 5 minus x to the 5th times 25 plus 5x to the 5th plus x to the 10th. All right, last one. X cubed, y cubed plus 343. Now notice x cubed, y cubed can be written as a perfect cube, and it's a plus. All right, so this is going to be x, y quantity cubes, because that's xy times xy times xy is xy cubed. Plus 343 is, if from our chart above, is 7 times 7 times 7. So if you're not sure, take the cube root of 343, but it's going to be 7 cubed. All right, following your pattern. This is a cube, this is a cube, there's a plus in the middle. Here's your bubbles, small bubble, big bubble. Same sign, opposite sign, always positive. All right, so your pattern for this, A is going to be xy, B is going to be 7. So, same, xy plus 7. All right, and this A and B stay the same. Now, what is xy quantity squared? Well, it's xy times xy, which is x squared, y squared. Multiply these together. A times B would be 7xy. And then B squared is going to be 7 times 7, which is 49. So, basically what you have to do in order to do the sum and difference of cubes, figure out what the cube roots are, figure out what the pattern is, know your SOAP formula, and how to apply them in the values. So, you need to know these formulas. You are not given them on the Regents. You need to memorize them.